Hey everyone, we're going to go ahead and do the demonstration for Lab 7 terrain. So if you get your file downloaded and pulled onto your Google Drive GIS folder, you'll see that you just have a few shape files in here. We've got some GPS points for interpolation, we've got contours, spot elevations, and water for the Michiana region, and we've got the parks right here. So like what I said in class, what we're going to do is a little bit different than how you would normally do this. We're going to go ahead and start off with creating a tin off of those vector data, the points, the elevations, the water, and the contour lines. We're going to clip those down to the park and create a tin out of them. Then from the tin, we're gonna convert that into an interpolate or into a DEM, and then we're going to work with some of the other ways of visualizing landscapes and doing some of the different analysis. So go ahead and in Pro, we're going to start off with a new map document. Load up. Just sending this off to my Drive folder. Eventually. GIS, and I already created the Lab 7 terrain one here. I'm going to call this 7. Just going to run it that way. All right. So when this gets going, so far we've done cropping of raster images, but we haven't done clipping of vector data to other vector data. So I want to just walk through that process as well. That's why I gave you that section that was kind of the parks there also. So once this gets all loaded up, we're going to go either through map, add data, or if you've got a catalog tab up, you can use that. And I'm just going to go back into my folders for Lab 7 terrain. And I'm just going to add in, I'm going to skip the interpolation GPS points for now. And I'm just going to add in the Michiana contours, spot elevations, water, and parks. And when we bring this in, you'll see that you have the outlines of the parks again, but then you also have these contour lines, water, and then the spot elevations. These are directly from the various USGS maps that we've worked with. So the first thing we want to do is we're going to take the parks here. I'm just going to move this up to the top and then click on this to make it transparent, just so you can sort of see where they are. And we're going to clip all of the other shapefiles to it. Now, when we did this before, people had a lot of trouble with making sure that they had something selected. So just make sure you do this either by clicking on it, or I'm going to go into attribute table. And I'm just going to select Notre Dame here. Now, when I run the clip tool, it's just going to do it for the selected thing. So ArcGIS, as just a reminder, always does things for what is selected. And to get to these, I'm going to go into the Analysis tab. And then there's a few ways I can get to this, but the one I'm going to choose this time is just going to click on Tools. And I'm going to search for clip. Could also get to the temporary versions of this through some of the other vector tools, but this is the one that's going to save new ones. So extracts input features that overlay the clip features. It's exactly what I want. Once it decides to run, I'm going to give it an input. I'm going to start off with spot elevations here. I just dragged it over, which is why it's taking a second. And my clip features are going to be parks. And then I do want to save this permanently. So I'm going to go ahead and I also want to use the selected records. If that comes up on the other one, make sure you don't, because you don't want to just one or two selected spot elevations. I'm going to go into folders, Lab 7 terrain, and I want to save this as ND spot elevations. That's not how you spell elevations. We'll just do spot 11. .shp and hit run. And for points here, this is going to look a whole lot like it would if we just did a select on it. So these come in. If I turn off my other layer, you'll see that it's only retained the ones that are within there. And if I have this tool up, I can just then change this from spot elevations to contours, and then just change my output from ND spot elevations to ND contours. This just saves me a little bit of time using the same selections, the same sort of things. And where it gets a little bit different is when I do this on lines, it has not just chosen the ones that intersect that thing, but it's actually cut them around the edges. So it's discarded the pieces of the same line that are outside of there. And if I do the same thing for water, you can see the river runs right through here. So it's going to have the same thing. And now I end up with, instead of the whole of Michiana, just the area that I care about in here. So I've got points, lines, and polygons for water, contour lines, and spot elevations. Now at this point, I can go ahead and get rid of the other ones that are in here, the contours, the Michiana ones, and probably get rid of the parks if I want to as well. I'm going to leave it in because there's one other thing I can do with it, but I'm just going to right click on these and choose remove. Because now we're to the point where we want to go ahead and create our tins. So we're going to make the new piece that runs all this stuff. This again is in analysis tools. You can go into toolboxes and go all the way down to should be 3D analyst, and then in there, tin data set, create tin, or you could just search up here for create tin. And there you go. Either way you get to it. So it's going to ask me for the output name first. I'm going to put this, you could do it in your database if you wanted to. Actually, I don't think it'll store them in the database. I think it has to do it outside of it. So I'm just going to call this ND tin. Tins are pretty long in terms of like what, like, sorry, they're pretty restricted in how long the file names can be. So just be careful that you don't make that too long. Do ND tin. I do want to give it a coordinate system, though it will sort of figure it out from other things. I'm going to go into my favorites where I have zone 16 north. If you've missed that, it's projected UTM, WGS 84, Northern Hemisphere, zone 16 north. Then I'm going to choose the input features for it. I'm going to choose first spot elevations. I do have a height field in there. It's called a lev. And the type that I want for individual points on this one is mass points. The next thing I'm going to do is hit this add another, because there's multiple things that I'm doing here. I'm going to go to my input features are going to be contour lines. In this case, I'm going to choose, instead of hard line, I want to choose soft line. That is so that if it absolutely has to, it can change, it can deviate from those things if I want to. And the last one I'm going to choose is ND water. Height field, I'm actually going to turn that off. I don't want a height field, even though it's in there. I do not want to clip them to these. Instead, what I want to do is what's called a soft erase. Sorry, soft replace, not soft erase. So soft replace is just going to make it flat in there. But again, it can deviate from that if it absolutely has to. Okay. There's a couple things that will happen. So if you look in here, I've got things that are around the corners where there's not points and all the way into the corners or lines. There are some ways I can trick it to go all the way out. One of them is to sort of make the edges into something if I need to. I'm not going to do that right now. Just know that the corners will be a little bit wonky if yours don't go all the way around. So I'm going to hit run. And then, you know, as quick as that, on something this size, I have the tin generated. And you can see if you kind of maximize it over here, that it's generated off of the points, lines, and polygons that are on there. If I turn those off, you can see it. It's got colored off of elevation so far, and you can kind of see, if you zoom in and out on it, you can see the triangles kind of popping up. They're not really readily apparent because style bend is pretty flat, but they are there and they do exist. Okay, so I'll talk about what we're going to do with this thing in a minute when we get into some of the other things we're going to work with. But I do want to show y'all as well the other kind of ways that we would do this sort of stuff. So another thing that we can do, we talked about this as well, is we're going to generate a DEM from this tin. We're going to use this tin to generate a DEM. If you go back into analysis tools, you can do tin to DEM. I'm sorry, tin to raster. It'll come up as regardless of what you search. So it's interpolating a raster off of the Z values from the input tin. I'm gonna actually store this as a file. So I'm gonna go into folders, Lab 7 terrain, and I'm gonna call it nd dem from tin.tif. That's just saying it's a TIFF file. The reason for that is just so I don't confuse this with one of the other DEMs that I'm going to create. Got a number of different output types you can do here. I would say in this case, I wouldn't really worry about it. You can do however you want to do these if you need to, but I would say just leave them as the defaults for now. We'll run this, and now you see that you have that DEM view as well, where it's going from a low height to a high height. Again, Northern Indiana, not exactly a huge amount here. You can click on this to get to the different color schemes. If you scroll down, your eyes may immediately pick out the ones that are usually used for elevation. They may not. You can always turn on show names, and then there are a couple in here that are flagged as elevation. So I would say go find one of the elevation ones, and that's the more traditional way of showing these things. All right. So the next thing that we had talked about doing was doing an interpolation for topographic data as well. So I'm just turning these things off. And I'm just going to add in one more piece of data here. I'm going to go to add data. Oh, just clicked on the drop down instead. And I'm going to add in those interpolation GPS points. And what you have is just a whole bunch of GPS points that I would love to claim that I walked all around this region and took these points, but in fact, I just faked them from something else. But these are sort of in like a view of what interpolated or what the density of points you might need to do a decent interpolation are. All of the interpolation tools, regardless of which one you're looking for, are in that analysis toolbar section. If you wanted to find them, you can go to toolboxes, and they're mostly down in spatial analyst. And then there's a section called surface that's going to give you, there's a section called interpolation, IDW, that inverse distance weighted, the Kriging we talked about. Some of these other ones are in here, trend surface analysis, splines are in here. We're just going to run these as a spline. You could do an IDW as well. I just want y'all to experiment around with where these things are. So I'm going to go into spline. My points are going to be interpolation GPS points. The field that I have is going to be elevation. I'm going to export this as just wherever I want to put it. I'm going to see it. It was giving me problems about the thing there, so I just want to see if that'll actually cause problems. So I'm going to call this Michiana spline.tif. And you've got some sections here. I would drop this back down to like 30 just so it matches the other things that we have. Yeah, so it is gonna give me an error because there's a space in the file name. The solution to that would be to go and copy this thing off of your Google Drive because it's the drive that has a space in there. If I do that sort of behind the scenes, I'm just going to take the interpolation GPS points, ignoring these are just temp block files, and I'm just going to stick them into, I have a folder on my computer called temp, but you can put them in my documents or something else if you wanted. And then I'm just going to drag it back over. So that's a situation, whoops, it's just yelling at me about that. So that's a situation where the warning that it's giving you is actually really, really useful. So I'm just turning this one off. Go to the other one. Shouldn't. Unless I grabbed the wrong one or something. Yeah, there's no spaces in there. I don't know quite what's going on with that one. Probably just because I have two versions of it in here. It's just giving me a little bit of a wonkiness error. Or I've just chosen the wrong one. Yeah, it probably just thinks that they're the same because they're both in here. All right, let's check it, like, see what happens if we just try to do an IDW. It might, yeah. Okay, well, I'm going to pause real quick and see if I can figure out what's going on here. Okay, so there is a little bit of a problem with running the interpolation here on the spline or the IDW. This is another situation where the input having a space in the file name causes problems, and my drive has a big space in the middle of the word that when you have it on your Google Drive. So the solution is I made a copy of those interpolation points just on my C drive. In my case, it was Windows temp. This is just a folder I have. You could put it in documents or drive or downloads or really anywhere you want to. The other thing you can do is rather than like having multiple copies of it open in your drawing order, you can always go in here and just find it on the C drive, or sorry, when the copy that's on your C drive. This is the one that's on my Google Drive, so I'll show you what the error looks like when I do it. Well, now it's not going to give me one because it's going to it, I guess, in a slightly different way. Let's see if it actually gives me an error. So regardless, I am going to change my cell size down to 30, just so it matches some of the other layers that we're bringing in. Number of points is how far out it looks. Weight is how much it weights into individual points. So if I run it, it seems to come through okay, even if I pointed it at the right one. So that's another potential work through there or workaround there is instead of dragging it over, just use the one from right here. It's going and it's happily doing all of those splines where it's pulling the rubber sheet and things like that. And you can see it kind of running reasonably slowly in the background here. Then it picks up and we should be pretty much ready to go. And when it comes in, it will be that nice interpolated surface. So because splines are usually used for topography, I believe it's going to come up with the same color ramp already, one of the elevation color ramps. But we'll see in a second when it pops up. All right. Well, that's going. Another thing that we were planning to do is I want y'all to be familiar with how to download some of the topographic data. There it goes. And you can see when it actually renders here. Eventually, so I should have renamed that to be ND spline. I apologize for that, but you might never use this thing again. So when it comes in, if I turn off the GPS points, you can see that it is a nice surface here. It also, like I said, it comes in as this kind of classified version of it. I'm not thrilled about that. So I'll often come in here and instead of having it be primary symbology classify, I would change that to be stretch and then use one of the elevation color ramps across it. You could also do that shaded topography one that's in there also if you really wanted to. So the last type of topographic data we're going to do is actually this one where we're downloading things from one of the standard data sources. So I'm just going to switch over to a browser here. And where we're downloading these from is the USGS Earth Explorer. So it's just earthexplorer.usgs.gov. It has been up for a while now, so I don't think it's going to go away anytime soon. But know that these things might change as the government switches priorities here in 2025 United States. You will need to get an account. Mine is already set. I can't really go and re-register for one, but you would go through and create a new account. It's usually pretty quick to get authorized to do it. And you sign in because mine is saved there. And then what we're looking for, the way this works is you have sort of search criteria, the data sets you're choosing, additional criteria, and then your results. First thing you do is find the location that you're interested in. You can just come and like click on the map if you know where you're going, if you happen to be able to spot South Bend rather easily. If you do not, and you can't off of the satellite map, you can just come over here into the US features, type South Bend. It'll give you some results. There is a South Bend in Nebraska. We are the one here in Indiana. So I'm going to choose that, and it's going to put a pin right on there. You can do polygons. You can do all sorts of other things by clicking. If you need to search things worldwide, you can do that. So once you have a pin on there, it knows where to look. So you're going to go to Datasets. And then when we come in here, this is where we get all of the things. If your list does not look like mine, it might be because you're not logged in. It might be because you are not authorized to have certain things, but they're usually pretty similar. So what we're going to look for here is in digital elevation, SRTM, and then we're looking for the SRTM 1 second, 1 arc second global. These are just some other products here. These are where you can get to some of the, like the GTOPR 30 that we talked about, some of these other things. Astro data have been moved out of here, so the Astro GDM is someplace else. But this is where you get Landsat data, land cover. There's all sorts of good stuff in the USGS Earth Explorer. So you can go to additional criteria or get it up here. In this case, there's nothing we need to set, but this is where you would set like maximum cloud cover percentage for Landsat, things like that. Go to results. And then you have there's only one entity because of the way that the SRTM satellites are tiled. You can click on this little footprint and it'll show you what area you're looking at. You can actually click on this and it'll show you the image sort of overlaid there, all your metadata, that kind of stuff. There is a bulk downloader you can use. If you look up here, you can see that I started a bulk download and never finished it. Or you can also just come right here and just download it right away. The options that you're looking for, these are some file formats that are not very commonly used outside of like really intense satellite imagery stuff. I would just choose GeoTIFF 1 arc second here. You can see it's about 25 megs, so it's not enormous. It will probably slowly download. If for some reason this fails, periodically, I will give multiple copies of it. So it's coming in as the thing that it's supposed to be here. I'm going to go down to Drive, My Drive, GIS, Terrain. So what this is saying is this is the like this is north 41, west 87. Those are degrees. That's roughly where we are. And then it's 1 arc second, and this is the version 3 of it. So it's just telling you something about it. So once that's in, we can go back over to ArcMap or ArcGIS Pro. I'm going to go to a catalog view over here. Oh, that's create features. That's not what I wanted. I'm going to go to folders. And if for some reason it doesn't show up here, this does not update automatically. So sometimes what you have to do is right click on it and go to refresh. And now I should have that thing. Just drag that over. And now I have this big DEM at about 30-meter resolution for the entirety of the region from space, from the shuttle back in the day. And you can really kind of begin to see some things about topography. So if I'm just going to change the symbology on it to be one of the elevation ones. And again, I'm good at seeing these, but turn on show names if you want, and you can find the elevation ones. So part of the assignment is to sort of assess the differences between some of these different ones. Obviously, some are bigger than others. If you look at satellite things, you can tell that they have, it's picked up on like a road right there and right there. Every once in a while, it'll pick up like a really tall, like you can see some buildings and things like that. That's just because it's sensing from space. So it's gonna see those things as part of the surface, not necessarily the land, whereas a topo map is going to assume that you've removed those. It's not going to give you contours for the tops of buildings and things. So just know those kinds of things are in place. So the next thing we want to do is look at some of the topographic analysis techniques that we've talked about. I'm going to start off by doing these on the tin because in some ways they're a little bit easier. In other ways, they're not as quantitative and you can't do as much with them. But if I want to change what I'm seeing on the tin, it's actually integrated in the file. So if I wanted to do the aspect, the slope, those kinds of things, it's integrated in the file. And in fact, I get to it by coming in through the tin and going into the symbology. So right now, it's in this place right here, but if I come to the actual tin itself and right click and choose symbology, it's going to give me more options. It just doesn't default to seeing them unless I'm clicked all the way up on the top there. So what it's saying is I have edges that I can see. Those are the lines and things like that. But what I'm probably more interested in is symbolizing the actual surface. So right now it's drawing it using elevation. but I can change it in the dropdown to be things like slope. You can see it's overall pretty flat, but you can see there are some slopes kind of as you get around the lake and so, or sorry, around the river and things like that. And I can change it to be aspect as well. So you can see that overwhelmingly it's pretty flat, but there are some slopes or some aspects of different directions in that case. So this is really what you can do with the tins like this is you're just sort of changing them as you go. You can't actually do much quantitative with them, but this is kind of a quick way to be able to see what the slope and aspect is because it's sort of part of the actual file and it's sort of integrated in there. You don't have to run a separate tool. It's all kind of part of the same thing. What's a lot more common, though, is that we do these things on a pixel-based raster DEM. And that's just because then those files can be the basis for lots of other stuff. So let's just go ahead and look at some of the different things we can do. So if we go to Analysis and Tools, if you're in Toolboxes, you can go to Spatial Analyst. And then this is where I accidentally went to Surface first. This is where almost all of these are. You can also search for any of these if you want to. The first one we're going to do is just running a slope. Our input raster. Honestly, it doesn't matter which DEM you use here. I'm just going to do it off of the one that is compared directly with the tin, but you can do it on the other ones also. I would like to, this one I think you should save as a permanent file because you will use it in future ones. I'm going to call it ND slope. .tif. Degree measurements, you can give it, you can tell it meters or not. It's going to start, if you have a GPU, it'll run it on there. This is not going to be an issue with ones this size. And you've got all these other settings you can do. So it'll run and you'll end up with a raster that's coded. Actually, it looks like they've changed the default colors since I was complaining before about that red to green one. They've changed the default to be sort of low to high here with the idea that this is comparable across many things because you have one like this. So the way you would normally view slope, oops, I'm just gonna go to symbology. This is a good way to do it. But if we were to go to the symbology on this one, somewhere I'll find it. I'll just right click and choose it here. So it's coming in as the sort of classified manual intervals through 9. You could just do it stretched as well. This is going to show you what's actually present in your thing. I think there's one in here that is slope, but I could be wrong. Yep, slope is right there. So it's colored that the high things are only 12, but you can see more clearly where things are. That's the more traditional way you would view slope. If you want to do aspect, it's very similar. I'm just back in geoprocessing 3D analyst or spatial analyst surface, and I'm going to choose aspect. Again, you're going to bring in your DEM. We call it ND aspect. .tif. This will probably do the same thing where it gives me these default colors. This one, it's good to leave it classified because of that problem with 360 being on, or 0 and 360 being the same thing. And you can see the flat areas are pretty apparent. Those will not be apparent if you run this on satellite imagery or if you run this on the interpolation because there'll be enough give in there. This is just because those contour lines from the very beginning when we did them, those were just really flat areas. So the contour lines didn't build anything out. We're going to go back. Another one we can do is that hillshade. Input raster again is your DEM. Call it ND hillshade.tif. You can choose the model shadows. You could set the azimuth and the altitude if you wanted to. Go ahead and hit run. Again, pretty flat area. It doesn't look like that much. This is a situation where we can come in and choose right here and go to raster layer up at the top. And if you crank that transparency up to, in the 75s or so, it will start to sort of look like three-dimensional like false three-dimensional. Again, it doesn't look good for this region because there's just not a lot of difference, but you can maybe start to see a little bit of shading like right next to the river. All right, another one we can do that is pretty useful, I'm gonna go back here, is this one called contour, where I'm going to take a raster layer, in this case, my regular DEM, and I'm going to spit out actually a contour shapefile. So I'm basically recreating the original contours that are in there. So I could call this MD contours 5 meter. It'll default to .shp. So I'm going to say 5. Base, you can leave zeros, you effectively leave a 0. Contour type, you can leave as contour. I don't know what else there is in there. Yeah, you could do shells and things if you needed to. You could do set maximum vertices if you needed to also. That'll just depend on how smooth it is. And what you see is that we have new contours that have been brought in just off of the raster itself. Just turning off everything but the actual DEM. And if you compare that to the original contours, they're okay. The intervals are different, but you can see they're generally sort of in the same place. Okay, the last thing we're going to do with topography is that visibility and terrain analysis that we've talked about before. So to get to this, we're going to come up here into analysis and head over to where it says visibility analysis. It gives us this little tool over here where we have 2 choices up at the top. We have a linear line of sight and a radial line of sight. Let's go ahead and start off with just a radial line of sight. I think this will give us kind of a quick overview on things. The very first thing we're going to do is choose the surface that we're working off of. In this case, you can do any of the DEMs that you want. I'm just going to use the DEM from TIN. You could use the satellite imagery, the interpolation, really anything that you wanted to. Then it's going to ask us about observer points. Remember, this is the point from which we're seeing something. You can have your choice of bringing in an already defined one. Do not do this for the interpolation or the spot elevations. It'll take forever. But what you can do is choose enter manually. If you come over here, it'll let you click on the map to do one. I'm just going to do one because it can take a little bit to run, but you feel free to do a few if you want to see what they look like. We can do this thing where we're symbolizing multiple observers. We can give it a name for all the output stuff that comes with it. What's maybe a little bit more important is we can set the height for the observer. It says surface, but this is just the target as well. So if you're looking at something that's 2 meters tall, then you put that there, and it'll be everything that's visible if it was 2 meters tall. And then you can do sort of fields of view and things like this. So once you've chosen a point and you've given it the DEM and you hit OK, what it's going to do is create a new sort of overview of what's visible from any given spot. So it's going to have it coded as sort of visible, not visible out to a particular distance. And of course, that distance is going to be dependent a little bit on atmospheric conditions, on things like that. So you can change those kinds of things. But in this case, we can just sort of leave it as is. Right now, it's saying a roughly 2 meter tall observer could see what from that particular point. So let's see what it looks like when it finishes off. Like I said, it can take a little bit to run one of these. And there we go. You see it's come up in the background. What we have, it's gone nicely zoomed it to us, is it's put everything into a grouped layer over here. It's given us this polygon of sort of what's visible and what's not visible from that point. So you can see that whatever's over here is sort of hidden by this slope that's coming down, but things that are over here are a little bit further out. And then it goes out to that particular radius, which you can adjust. So the other way to do these, mine just came up as 2 because I'd run one previously in a different recording. So if yours looks differently, don't worry about it. The other way to do these is this profile sort of view up here. So if we do an input surface here, again, I'm going to put it on the DEM. In this case, we can give it points as well. And it's going to basically just give us from those 2 points, and then I'm doing target points, what's visible to other ones for this linear line of sight. Same observer options would be present. This should go a little faster because it's not doing out the sort of radial thing. So it's going to show us sort of what's visible from one line to another. You can see it doing all its magic behind the scenes, locking and unlocking layers, that kind of stuff. So it's created the lines sort of connecting each one, and then it's giving me this sort of visible, not visible between the different ones. So if we were looking from first point here, we cannot see, we can see the other point if it's high enough. We can't see all the things in between. From this point, we can see what we can't see between them. So you can see there's a little ridge in the way there that's sort of blocking this one. Now that's useful, but another way we can do this sort of thing is through actually creating a profile chart also. And this one's a little bit hidden in one of the toolboxes here. So we go to Analysis, Tools, and then you can do Find Tools. It's actually, I can show you where it was if I needed to, but you can just basically choose Profile, type in Profile, which returns elevation profile for the inputted line features. We can, again, if we had line features, we could use them. And in fact, we can do that here if we wanted to do the sight lines in this one. We can also just choose in the drop down or over here to just enter a line across. So we've created a new one. If we wanted to give it the DEM resolution or anything like that, we could do that. In this case, they're mostly, if the satellite one is 30 meters, the other ones would be a little bit different. So we're going to run this, and this one's actually going to look at canned data. We don't actually have to have a layer that we're pointing it at, although there are ways to set it if we wanted to. So we'll end up with the profile over here. It looks like nothing has happened, but if we click on it, you'll see that we've got some other things up here, and one of them is data. And if I choose data, I can come in here and I can come over to create chart, and I can do profile graph. And now from that line, I have this nice chart that's going to come up that shows me for that line sort of what's visible along there. And if I were to go back into profile here and change the input line features to be the sight lines from that linear line of sight that I did and run that one. Oh, I meant to set the profile ID field, but it's fine. It'll show me the same sort of thing, but for these ones that are coded in there also. So I have my new output profile. In this case, if I go to data, create chart, profile graph, you see it's showing me for those lines also. So I can bring in other lines, I can bring in different things. And this is just sort of coded from the beginning of the line to the end of the line. And there we go. If you do run into a situation where you're doing one of these tools, particularly in the visibility analysis thing here, and you run into a section where one of these layers has a red box around it and it won't let you click OK. This is a little glitch that's happened in the program. Some of these layers will come in as very, very slightly projections, very, very slightly different projections. If you need to fix that, double click on map over here, go down to coordinate system. Inside of layers, choose the coordinate system that matches. So you choose to have it match the output. So if you were trying to match this one, it's largely because of that. You would choose one in here and just make sure that it's on the same one, and you should be good to go. It'll take away the red box, and you'll be able to run it.